We have completed the first step of providing engineering data. Next is, you can see the green tick here, it's mean it is done. Next is creating or providing a geometry. We'll right click in on it and we'll say new space claim geometry. It will open a space claim interface which we have already seen in practical one. You can see here status bar, it says starting space claim. So let's wait it to open. Space claim interface is open. First step is to check the unit. I will go to the file and will say space claim option. Under that I will go to unit and will make sure that type is metric and length is in millimeters, right? That is what our problem statement units are. Next is I'm going to create 3 lines representing the mid line of a cross section, and then I will provide a cross section of our step bar to those lines. Remember, we are doing a 1D analysis. Why 1D analysis? That is being already discussed in lecture 1. So let me take a new sketch plane. I will right click and will say new sketch plane. You can select from bottom button also. I will say new sketch plane. I will select XY plane by clicking in between XY plane. Then I want to see in a plan view. I can go here or bottom or just press V button from keyboard. So that is normal look of a plane. Next, let's create 3 lines of 100, 80 and 60 mm representing the 3 steps. We'll go to design, sketch, we'll select a line. Make sure here on the uppermost left corner you are having snapping to curve center and agreed. Then I will move along X, will press tab and will type 100. I will use control and middle mouse button to pan it. Then I will again move forward in X direction. I will press tab and will type 80. Again I will move in X direction, will press tab and will type 60. So this way we have created 3 lines. I will press escape button from keyboard and will return to 3D mode either from above context menu or bottom buttons, or just pressing the D from keyboard. We are now in a 3D mode. You can rotate using middle mouse button, holding and dragging. So we have under the tree, structure tree, we have 3 lines created, right? 100 mm, 80 mm and 60 mm line. Now next step is to assign the cross section to this lines. So we'll go to the prepare context menu. Under the prepare I will go to the profile. So let me first create profile and then we'll assign that to the respective curve lines. So I'll go to the profile. We'll assume that here in problem statement we don't know the cross section of bar, right? So we are assuming that the step bar is having a rectangular cross section. So it's not necessary to select a rectangle, but it's just general profile and simple. So we'll select a rectangle, solid rectangle. As soon as I click on solid rectangle, here under the structure tree, under beam profile, one rectangle profile is being selected. So I'll click on rectangle. The area shows 100 mm square, but my area is 1000 mm square. So I need to right click and will say edit beam profile. Under edit beam profile, I see the graphics window and a new tab open. Now I cannot change the dimension of graphics window. That's the issue here. So we have to go to the tree here, group, and we'll click on the driving dimension B. The width is, we know the area is 1000 mm square, right? So it's square profile. It means that the one side will be root of 1000, right? So square root of 1000 will be giving you the width and height. So square root of 1000 is, per calculator, it is 31.622. So let me type 31.622 let me go to the 4 digit 6227, and similarly height also 31.6227. So we have provided the ruler dimension to the cross section. Now let me exit it. I will exit this, will go to the structure, and then I will click on a rectangle. Now I can see the area is 1000 mm square. I will just right click on this rectangle and will say rename of 1000. So just in case I will be able to identify while assigning the profile to the lines. Next is, we again want to create another rectangle. You cannot right click and duplicate it, these things, because if you change the second one, it will automatically change the first one. We don't want that because areas are different. So I will go to the rectangle. I will say new profile. Again I will select solid rectangle. Rectangle area is 100. Our is not 100, our is 500. So I will right click and will say edit beam profile. We'll go to the ruler dimension and we'll click on 10 mm and we'll change it to 22.3606. right? So that's the square root of 500. Similarly, height of cross section is also going to change to 22.3606. So we have defined a 500 mm square cross section. I will close this system tab from bottom. We'll go to the structure, we'll go to the beam profile, we'll go to the rectangle, and you can see the area is 500 mm square. We'll right click and we'll rename to 500. Next is, we have to create a 300 mm square area. I will go to rectangle, new profile, rectangle, we'll right click on rectangle, edit beam profile. Under the ruler dimension, I will click 10 mm and we'll type 17.3205. Similarly, H also, I'm going to change to 17.3205. 17.3205 is the square root of 300, right? I'll close this. We'll go to the structure. Under beam profile, I'll click on rectangle. The area is 300 mm square, right? We'll just right click and we'll say rename to 300. We have created a beam profile. Now next is to assign this beam profile to above lines. So let me go to the isometric or trimetric view. We'll say select first 1000 mm square cross section and we'll say create and will it assign to this one, first line. From graphics, or you can select from the curves in the tree. If you are not able to visualize this rectangular cross section, you can go to display and activate this solid beam view. Next, a 500 mm square profile, that is to be assigned to second. Third, 300 mm square, that is to be assigned to this third line. We just have to click on the line. So I've created the 3 cross section. I will press escape button. Now the curve folder is being replaced with the beam folder, and each beam is having a cross section assigned. As you remember from the first lecture, we are making the midline representation of this cross section. So if midline is deforming, that cross section is deforming, right? So that's what 1D simulation assumption means. Next, and very important steps which generally students forget is to do the sharing. Means these beams are right now acting as a separate bodies. We have to join this. We have to provide a joint here. To do that, we'll go to the workbench, and there is one option here under workbench, share. So if you click on a share, the answers will highlight here, and here you have to provide a sharing, and we'll click on the complete button, right? So there it is being joined. Now the geometric modification is done. I will say file and we'll say exit space claim. We'll save this. Second step is completed.